For way too long, manufacturing has been stuck with this kind of broken model, right? You've got design happening in one software silo over here and manufacturing in a totally different one over there. Today, we're going to dig into the massive business case for finally connecting those two worlds. We'll see how a single integrated platform can totally transform an entire operation.
Okay, let's just kick things off with a number that, well, it's pretty staggering. $2.3 million. A recent Siemens report found that's the cost of just one single hour of unplanned downtime at a big automotive plant. And as crazy as that number is, it's really just the tip of the iceberg.
You see, a number that big isn't just about a machine breaking down. It's a symptom of a much deeper problem. It really makes you wonder, what are the hidden costs? All those little leaks and process gaps that are draining your business right now, day in and day out.
To answer that, you actually have to look past the machines and focus on your people. Because the real cost of being disconnected isn't just downtime. It's the valuable, irreplaceable time your team is losing every single day.
Think about this. It's like losing one of your best engineers for an entire day every single week. No joke. According to research from TechClarity, that's pretty much what's happening. Technical folks waste almost 19% of their time on stuff that adds zero value. Hunting for the right file, recreating data that got lost, or just battling with different file formats. It's like a constant state of digital friction.
So where is all this waste even coming from? Well, it stems from something we can call the standalone tool trap. It's this super common but deeply inefficient way of working, where you're using separate, totally disconnected software for design and for manufacturing.
The heart of the problem, really, is data translation. See, when an engineer exports a design from their CAD system to send over to the CAM system, it's not a clean handoff at all. That process strips out all the important design intelligence, the why behind the geometry, and it leaves behind just a dumb model. The link to that original design? It's gone, permanently broken.
And this is what that broken link looks like in the real world. In that standalone workflow, any little design change means you're basically reprogramming the whole thing. The risk of accidentally making a part from an old file is always there. But in an integrated workflow, the toolpaths just update automatically. Everyone's working from a single source of truth. It's the difference between constant, frustrating rework and a smooth, continuous flow.
So if the problem is a broken link, then the solution is obviously to build an unbreakable one. This is what the industry calls the integrated digital thread, a single, unified environment where design, simulation, and manufacturing are all speaking the same digital language.
And at the heart of this whole digital thread is the master model. It's a really simple idea, but it's totally revolutionary. Instead of emailing files back and forth, everyone, from the designer all the way to the machinist on the floor, works on the exact same native data file. No translations, no broken links, no lost intelligence. It's that simple.
Let's look at what that means for your team. The old way, a design change comes through and your programmer basically has to start all over again. It's a nightmare, but with a live associative link, that same change automatically flags the toolpath that's affected. The system knows exactly what changed, so you can do a quick, smart update instead of a complete do-over. Just that one change can slash design cycles by 50%.
But look, integration isn't just about avoiding rework and fixing problems. It's about proactively automating your manufacturing intelligence. It's about making the software do the heavy lifting for you.
So just imagine this for a second. What if your software was smart enough to look at a 3D model and already know the best, most efficient way to machine it, all based on your own company's best practices? Well, it can. This is the power of something called feature-based machining. The software doesn't just see a bunch of lines and surfaces. It intelligently recognizes manufacturable features, things like holes, pockets, and slots. And then it automatically applies your company's predefined best practice machining process for that specific feature. The impact of this is just enormous. First off, you can cut programming time by up to 90%. That's huge. But maybe more importantly, you capture all that tribal knowledge from your best machinists, and you turn their expertise into a repeatable, standard process. This frees up your most senior people to stop programming simple parts and focus on the complex, high-value jobs that actually drive the business forward.
Now, the last piece of this intelligence puzzle is validation. The old way, toolpath simulation, is kind of like a video game of what the software thinks is going to happen. It often leads to these super risky dry runs on the actual machine. The new way is G-code simulation. It simulates the actual G-code, the language your machine speaks, on a perfect digital twin of your machine. It validates every single move and prevents those catastrophic collisions before you even think about cutting a chip.
All right, the tech is really impressive, no doubt. But what does all this, the master model, the automation, the digital twin, what does it actually mean for the bottom line? This is where we get to the multi-million-dollar payoff.
The data we have from Lifecycle Insights is, well, it's pretty stark. Companies that really embrace these integrated digital platforms, the most progressive ones, they hit their manufacturing throughput targets 72% of the time. Now, those who are still stuck using disconnected tools, they only hit their targets 64% of the time. Now, that 8% gap might not sound like a huge deal, but let's put it into perspective. For a company with $100 million in potential revenue, that gap represents a $7 million opportunity. That's revenue that's just being left on the table right now, lost to old, inefficient processes.
And we're seeing this happen in the real world. Take Princess Yachts. They use an integrated CAD/CAM environment to manage incredible complexity, bringing 6 entirely new multi-million-dollar yacht designs into production every single year. That's a kind of speed and agility that's just impossible with disconnected tools.
Or look at Wright Medical Technology. They're in the super regulated medical device industry, and they used an integrated system to shrink their design approval cycle from days down to just hours. They're getting critical new implants to market and to patients faster than ever before.
The proof is just everywhere. Grob, a global giant in machining systems, they implemented just one piece of this puzzle, that automated feature recognition we talked about, and they cut their CNC programming time by 30%. 30%. Just think for a second what that would mean for your operations.
So, the takeaway here is pretty clear. This shift to integrated manufacturing isn't some futuristic idea, it's happening right now. We've seen how it gets rid of waste, automates intelligence, and drives way higher throughput. It adds millions to the bottom line. The evidence is just overwhelming, which really leaves only one final question. Your competition is building their digital thread. Can you really afford not to?